Hello, good morning, good evening, good afternoon, happy Saturday, whatever day it is, Sunday, Monday. And this is the third video on the standard form, vertex form, and today is focusing on the factored form, also known as intercept form of quadratics. So standard form, remember we talked about, we have ax squared plus bx plus c. A tells us if it opens up or opens down, if it's negative, if it's number greater than 1, then we know that's going to be absolute value greater than 1. We know it's going to open up narrower, and if it's a fraction that's between 0 and 1, then it's going to be wider, and C is our y-intercept. And then vertex form, we learned that our HK is our vertex here, and A does the same thing as says above. And then now we're going to talk about factored form. So factored form looks like this. It is f of x again. A again, same thing as before, opens up, down, wider or narrower. And then it's the factors, so the parentheses, x minus p times x minus q. And p and q are really important numbers in this because it's going to tell us about what our intercepts are, which is where it crosses the x-axis. So intercept form, that's why it's called that. It helps with the x-axis intercepts. This one helps us with our vertex, and this one helps us find our y-intercept. So let's get started with our notes. All right, axis of symmetry. So if we are in factored form, then our axis of symmetry, which is our ALS, our axis of symmetry is found by going x equals, take the p value, take the q value, and add them, and then divide by 2. So what it's doing is taking your x-intercepts and it's dividing it in half to find the middle of your parabola, or that axis of symmetry. And so remember we have x minus p, and if it's x minus p, this is the format, so if it's like that, then we have a positive p value. And if it's x plus p, then it meant it was x minus negative p, which means that now our p is negative. And same thing for our q value. If it's x plus, so x minus q, then that tells us that our q is a positive number. And if it's x plus q, then it tells us that q is negative. Again, that's because this really is x minus negative. And same thing here. This would be an x minus a negative q, but mathematicians don't want to put minus negative. They're going to go plus a positive. So that's why they are that way. So you kind of saw that when we were talking about the axis symmetry before, when we had in our vertex form. This was x minus h, and h is positive. This is x plus h, where h is negative. Same reasoning y down there. So it's the same thing here. So we're really looking at x minus p, p is positive, or x plus p, p is negative. And same thing with our q. So that's our axis of symmetry. It's going to find the middle of our parabola, and our x-intercepts are going to be on either side of that. And so our vertex, we know our x. So just like when we had standard form, our vertex, our x value is this p plus q divided by 2. And then when I plug that in, I'm going to have f of p plus q divided by 2. That's going to be my y. Remember, it's x comma y. And so this value here is what you get when you simplify with p plus q divided by 2 for x. All right, so that's just like what we had with our standard form. You take your x value that you got, so say it was like -3, plug it into your equation, see what you get when you're done, and that's going to be what your y value is. The important part about the intercept form is that it tells you your x-intercepts. So that's why I really care about this. And remember, x-intercepts is where it crosses the x-axis. And so our x-intercepts are whatever that p-value was and 0. And whatever that q-value was and 0. So I always kind of look at it like, okay, if I want this to be 0, look at my form. If I want this to be 0, what does x have to be to make that 0? Oh, well, that would have a p. And then if it's in the form of this, that's like x plus q, what do I have to put in there to make this to be 0? Oh, it's the opposite of q, which is why q is negative. And you're going to see us practice this a lot. Okay, but those are my x-intercepts, and that's the important part of this type of expression or form of quadratic functions is for our x-intercepts. And in our warm-up now, you've seen us go from our standard form that we had here, and we factored it out. Now we ended up with our intercept form, and the one in our warm-up we had perfect squares. So then we ended up with this form, which is our vertex form. So we're going to do a lot of practicing and going back and forth between the forms. All right, so let's do an example to make this make sense for us. Help it make sense. So our example is f of x equals, I'm going to write that in pen so you can see this part better. F of x equals x plus 3 and times x minus 1. So this is x plus 3 and times x minus 1. Then I know from this that my intercepts, my x-intercepts, are, I'm going to look at this and I'm going to look at that. To make that become 0, I need a negative 3. So I know my x is negative 3, and that would make that 0. And then if I put this in here, I want what makes that 0. So that's opposite of this, so it's a positive 1. So I know that's my x-intercepts. And so I'm going to plot those points first. So I'm going to go to my graph, which is right here, and I'm going to start, this is my 0 over 1, 2, 3 right here. Nope, just kidding. This is my axis. Okay, and my lines didn't print very nicely. So I'm going to start here, 1, 2, 3, right here. This is my 3. 1, 2, 3. That's my negative 3, 0. And then I go over 1, 0 right here. All right. So that's going to be my x-intercepts. And now I'm going to try to find where's the middle of those two so I know where my axis of symmetry is. And this a value, notice this a value here, there's nothing there. So if there's nothing there, then we know that is this invisible 1, which means it's going to have the same opening and closing or same dilation as our x squared, as our parent function. So it's not going to have a stretch, it's going to have that same pattern. So now I want to find my axis of symmetry. So I'm going to go, okay, well, x equals, and I'm going to use this format over here. It's the average of the two. Add them together, divide by 2. So remember, we have, this is a plus 3, so I know that this p is actually a negative 3. Plus, and that's what we have here. This is minus 1, so I know my q is a 1. So we can put p equals negative 3, q equals 1. That might help for both of that and down here. And then I'm going to divide it by 2. So negative 3 plus 1, well, if I have 3 negatives, I'm going to add a positive to that. I have negative 2. And I'm going to divide by 2. So x equals negative 1. And so that tells me that my axis of symmetry is at negative 1. So I'm going to go back to my graph. Here's my origin, negative 1's right here. That's my axis of symmetry. So I'm going to draw my dotted line there. And now my vertex is somewhere on here. I've got to figure out where that is. So my vertex is going to be, what do I get when I plug in negative 1 and simplify? So I'm going to find, okay, what is f of negative 1? Well, that would be f of negative 1 equals, plug in negative 1 where I see an x, negative 1 plus 1. Now, negative 1 plus 3 gives me positive 2 times negative 1 plus 1 is 0. Ooh, it's 0. Nope, I made a mistake. Where's my mistake? X minus 1. This should be negative 1 minus 1. Go back and fix that. Ooh, Miss Merlin makes some mistakes too. Did that on purpose. Just kidding. So, negative 1 minus 1 gives me negative 2, which then equals 2 times negative 2 is negative 4. So that means that f of negative 1 equals negative 4. And my x was negative 1, so my vertex is negative 1 comma negative 4. And that's my vertex. And so I'm going to go to my graph, and I'm at negative 1, negative 4. So 1, 2, 3, 4, right here. And remember that we're not making V's, we need a parabola, so it's easiest to find the points between these two, and that's going to help us make a nice U shape and not a V shape because it's not absolute value. So remember, if A is 1, A equals 1, then that cool pattern of over 1, up 1, over 1, up 3 works. And then we can even go over 1 and up 5, 1, 2, 3, 4, 5. And then same thing on the other side. Over 1, up 1, over 1, up 3, over 1, up 5. Now I can make a nice U shape. So this is over 5. So I can come down. I'm making a U, and I'm going to go back up. So I'm decreasing. I hit my parabola, my vertex, and then I go back the other direction. And a nice smooth curve, not a V. Okay. And now I know, let's put some information on here. My vertex is negative 1, negative 4. And this right here is an x-intercept. And that's the point, so we said 1, 0. And that's an x-intercept. And that's the point negative 3, comma 0. So we've just graphed now using our intercept form. And you could take our intercept form and make that generic rectangle, multiply it out, and then you could get the standard form for this function. And then if you wanted to, you could then again multiply it out or figure out, complete the square so you can get your vertex form. So that is our factored form example. We're going to practice this a lot, going back and forth from all three. All right, that's it, folks. Hope you have a good afternoon, good evening, good night, good weekend, happy 3-day weekend. Whatever you're doing, be safe and make good choices. Bye-bye.